Hello friends, welcome back. Hearty welcome to you. As part of Polynomials NCERT 9th grade syllabus, let us look at concept related to remainder theorem and some examples so that we can complete the exercise related to this. So first let us take two numbers and try to find out the remainder. Let us say suppose I am trying to divide 17 with 7. So what I will do, I will take 17. I will divide with 7. 7 2s are 14, and then we know that the remainder is 3. Now similarly, suppose you have to do the same thing on polynomials. Let us say suppose I have to divide x square minus 6x plus 11 with x minus 2. One way what we can do, we learned long division, so we can use long division and try to find out the remainder. The other way how you can do is remainder theorem. First let us see how we can do that with long division. X square divided by x is x, so x into x is x square minus 2x. Let us subtract them. We will have minus 4x plus 11. Now minus 4x by x is minus 4, so minus 4x plus 8. The remainder is 3. Now we know that dividend equals to divisor into quotient plus remainder. Dividend equals to divisor into quotient plus remainder. So why can't we go ahead and write down x square minus 6x plus 11 is equal to x minus 2 into x minus 4 plus 3. Now the other way to find out the remainder is, suppose I substitute x equals to 2. This is polynomial of x, right? Suppose I substitute x equals to 2. What will happen? 2 minus 2 into 2 minus 4 plus 3. Now we know that 2 minus 2 is 0. That means 0 into anything will become 0. So left out is remainder 3. Now this is easier way when we compare to doing with the long division. Now this is remainder theorem. What it says? The remainder theorem says that if a polynomial p of x is divided by p of x of degree more than or equal to 1 is divided by a linear polynomial x minus a, then the remainder is p of a. What we did here? We took the linear polynomial. What is the x minus a? What is the value of a? Or find out the 0 of this linear polynomial, that is nothing but equal to 2. Now substitute 2 wherever you have x in the polynomial. You will get the remainder. So that is remainder theorem. So let's write down remainder theorem. I will repeat again. If a polynomial p of x of degree more than or equal to 1 is divided by a linear polynomial x minus a, then the remainder is p of a. Let's write down that. We can write down if a polynomial p of x of degree greater than or equal to 1 is divided by a linear polynomial x minus a, then the remainder is p of a. Let's take one example to do this. Let us say suppose we want to find out the remainder. Our p of x is x to the power of 4 plus x cube minus 3x square plus 11x minus 37. Now we want to divide this with the polynomial x minus 1. We want to find out the remainder. So one way what we can do, take this as our dividend and this is our divisor. We can do the long division. Otherwise what we can do, simply we can substitute x minus 1 equals to 0. that means x equals to 1. So first step is to find out the 0 of the linear polynomial, that is equal to 1. Now come back here and substitute 1. P of 1 equals to 1 plus 1 minus 3 plus 11 minus 37. 1 plus 1 is 2, 2 minus 3 is minus 1, minus 1 plus 11 is 10, 10 minus 37 is minus 27. Now that is how we can find out the remainder. Let us try some more problems. There are two types of problems. One, we can be asked to find out the remainder. Other is to find out the unknown value k when we know the linear polynomial and the remainder. Like this example, we have been given a polynomial that is 3x to the power of 4 minus 4x cube minus 3x plus k, and it is divided by a linear polynomial x minus 1, and the remainder is minus 5. Then we have to find out the value of k. Now for that, what we will do? Again, x minus 1 equals to 0. That means x equals to 1. Now we will come back and substitute x equals to 1 in the polynomial. So p of 1 we know, that is remainder equals to minus 5. Substitute 1 in the polynomial. We will have 3 into 1 to the power of 4, 3 minus 4 minus 3 plus k is equal to minus 5. So that is minus 4 plus k is equal to minus 5, or k equals to minus 5 plus 4, which is equals to minus 1. So the value of k is equals to minus 1. So these are some simple examples related to remainder theorem. The problems can be complicated where they can give us two polynomials having two unknown constants like a and b, and they will give the remainders when they are divided by two different linear polynomials. So we'll get two equations, write both of the equations and try to solve them to get the values of a and b. Let's have a summary of what we have discussed in this session. Remainder theorem. If a polynomial p of x is divided by a linear polynomial x minus a, then the remainder is p of a. Now there can be 2-3 types of problems. The first problem is directly to find out the remainder. So for that we will take the linear polynomial, equate it to 0, get the 0 of the linear polynomial. Now come back and substitute that in our p of x, and we will get our remainder. The second type of problems is where we have to find out the value of k or a or b, something like that. In that we will be given the linear polynomial, we will be also given the remainder. So we will substitute the 0 of the linear polynomial in the given polynomial and equate the remainder to the given value of the remainder. So you can find out the value of k or a or b. The problems can be where they can give you two different polynomials divided by two linear polynomials with two different remainders. Then we will get two equations. Solve them, we can find out the values of a and b.